Okay, so let's take a look at what happens when my Radicand actually contains more power. So in the last video I was a little sneaky, I had that, but we just kind of worked around it. But in this case we really need to take a look. So to start our little journey, let's consider x to the 3/4 power. Now what we learned basically way back in the past, that 3/4 can be written a couple of different ways. We can write this as 3/1 times 1/4. Right? Or we can write this as 1/4 times 3/1 using the commutative property. So when I'm looking at this, I can rewrite this as x, right, to the 3/1 power, right, to the 1/4 power. Now why in the heck did I do that? Because what we also learned way back in the day is we have the power of a power rule. Right? That old rule was this guy, that if I have an exponential expression and it's being raised by an exponential expression, then I'll keep that base and I will multiply my exponents. So using this and using this, now hopefully you can understand what I did here. I just rewrote x to the 3/4 as x to the 3/1 times, or excuse me, raised to the 1/4 power. Using this rule, this becomes 3/1 times 1/4, which is 3/4 again. All right, so I didn't do anything too crazy there. I'm just using some old stuff, what it means to multiply fractions and what it meant to raise a power to a power. Now how does this help us out? Well, take a look at that statement right there. Right, as far as we're concerned, this 1/4 applies to everything inside here. 3/1, well, this is just x to the 3rd. So let me continue going out here. So this is x to the 3rd all raised to the 1/4 power. And of course we just learned that when I have a 1/4 like this, we're talking about the 4th root of something, and everything inside there becomes the exponent. So that would be one way to rewrite x to the 3/4. So you'll notice almost nothing changed. The 4 is the index, so it goes down into the index, right? The denominator is the index. The power, right? The base becomes the radicand. The only thing that's new is we're used to seeing this to being the first power, but it's the 3rd power, and it basically just follows that radicand in. It becomes part of the base. Okay, so that's one way we can write that. So in general, right, we can say that a to the m over n, we can rewrite this as the nth root of a to the m. So I can put this power inside the radicand, and that denominator is always going to be the index no matter what. However, we have this guy in play as well. Another way we could have written this is to say that this is x to the 1/4 to the 3/1 power. Now again, 3/1 is just 3. And again, using this rule, this is just a fancy way of writing 3/4 again. But now look at where that fractional exponent is, right? The 1/4. So this becomes the 4th root of x inside those parentheses, and all of that is being raised to the 3rd power. So that tells us that the power can basically be inside the radical, or the power can be outside the radical. So that's pretty crazy. So another way to write this is to say that this is the nth root of a risen to the mth power. So we have two ways we can write it. Where you want to put that power depends on the situation. Sometimes we'll want it inside, sometimes we'll want it outside. It's just that the good news for us is that there's two ways to say the same thing. And so that's how we handle a power in the radicand. We can either keep the power inside the radicand, right, or we can move the power outside of the radicand and apply it to the whole radical. And it basically comes down to your rules of exponents. And as you can see, right, I kind of keep sneaking them in at you, and they're going to play a role. As a matter of fact, the next video, that's all we're going to do is revisit this idea of an exponent. Okay, so let me go ahead and I'm going to stop this video because it's already about 5 minutes long. Here's our rule. When I come back, we're going to use it to do things down here on the bottom.